we will complete the sorting including bubble and we'll start with bubble first. In bubble sort we swap adjacent elements. If the one is smaller then we bring it before, and the one which is bigger we will pass it to the end. So let's try and 4 to 7. First we see that this 4 is greater than 2. Yes, so I will swap it. Now we see 4 is greater than 1. 4, 7. Then we see 4 is greater than 7. No, means that is and in first pass our last position of the vector is already sorted. Means the largest element in the vector which is present anywhere in the vector should be reached at last. So this is last. And now I don't want to go to here. I don't want to compare this with anyone because this is already sorted. If I compare this with any index or any element of this array, then I always found that this element is greater and there will be no swapping. The condition is not fulfilled that the element which is comparing with another is should be lesser or should be greater for swapping between the elements. So in second pass I will go to 1/4. So I see that 2 is greater than 1, is it can be swapped. Then I see this one is 2. Then I see 2 is greater than 4. No, this is the second pass. All of this index is sorted. Now what matter is 1, 2. I see that 1 is greater than 2. No, so there will be no swapping. So we need 3 passes for sorting 3, 4 element. We need 3 passes for sorting 4 internal element value. Here this is because the array is 0 index. So it should be around 0, 1, 2, 3. That's our reference. I will write the code with the comments so that you understand it better. This I am declaring the function which is a different type of void. And for passing the value we need a vector or array, or in some other programming we need this number, list or something. So for passing the value first for int I. This is 2 for passing values. This is to compare. This is to, as we know that after first pass the last element is sorted after 0th pass means the first pass the n minus 1 index, so n plus index n minus index n minus index n minus 1 index which is the last index of the vector will be sorted. So there is no comparing and rearranging. If array field the current element equals to primary array of g plus 1 as we swap. If you want to swap descendingly, if you want to swap from if you want to sort the array from largest to lowest descending order, then the sign will be removed. If there is no plus, there is no need to declare determinator here. This is the code. We pass the value we pass the array for first time, then we bring the largest element of the array into the next position. After passing first time, we are considering the n-7 elements only because the last element is already sorted. This is all about the sort. This is the trial. You can try any more proof. Now we will go to the selection sort. Now the main method of selection sort is to first declare the main method of the selection sort is to select the elements with the element which is minimum in the array and place it in the first position. So what we do, the main method is to declare a temporary array and then fill the temporary array from the beginning. As you find the x1, so I will try. Suppose that we have one nums 7, 3, 8, 2. So I declare a temp of size nums dot size which is empty initially. I traverse in num side. Find minimum index which is 2. I copy this 2 into this position and then I replace this 2 with int max. So now this will not be founded when I traverse again. I traverse in nums. I will find minimum index which is 3. I pull it to 3 here. I find convert it to int max. I go there again. I find int max. I traverse in int max. I keep it here. I traverse again. I find the name. I keep it here and replace it with int max. So this I like the selection sort. In best case, double sort complexity is big of n. In worst case, it's of n squared. And language is also of n squared. And again, neglect the use of temps. And then I copy temps nums. So my way of sections are different. Scenario, I declare int minimum index means the index of element which is the initial to now I am traversing an array. I will write the comments. I'm checking the condition whether the minimum index is equal to is open to frequency 0, so go with that. After finding the new index, I think I did something wrong. Find it here. I'm changing the social. Something wrong. I'm not writing comments now, so forward something. I am passing here, fitting the values in the ith position. For ith position, I find the minimum index here. Especially if I write it as I. And here for the ith value. I find the minimum index in the array. It's good. I think. I copy elements of time to noise. I can't write it. Don't write. Where it has to keep both and declaring the index. This is to copy the type place. Declaring variable for finding an index. This is to check in using variable. Let's try another program. Data set. Let's say information of time. This is the best case. Okay. So let's start. I is 0. Minimum index is I. As it is also 0. I want to clone the root this one. This will be. I find that nums of 0 is greater than nums of g, which is what?
Bluetooth mode.
G is what? So our area of 1 is less than minimum index. So the minimum index will be we no index is okay. We went to temp of 0. I think it should go there. So we are not here. We will find the whole array which is min index. This is equals to 2. So minimum index is equals to 3. Minimum index is 3. Equals to 4. Minimum index is 4 because we are comparing with 10.
तो इसमें एक असाइनमेंट में क्वेश्चन दिया था if n strings each of length n are given what is the time complexity to sort them strings को sorting क्या क्या n string each of length n हाँ are given then what is the time taken to sort them strings की जगह array होगा ना
modified arrays because we convert this 6 to
अरे ही मान लो
array मानेगा तो आसान है
कितना होगा
तब तो बहुत आसान देख
मतलब 2D एरे होगा ना फिर तो
and this one
नहीं
we can
अगर
do.
हम 1D array माने तो फिर एक array को सॉल्व करने में हमें लगता है
नहीं देखो क्या बोला
And in this way we can do it all. I'm not going to make it more complicated in this style because I have covered all of them. So we'll go with instruction sort. In instruction sort, we take a value or element and compare it. Its worst case time complexity is n square in all cases not separated. We take a value and compare it with its previous all its previous element. Which are larger than till we find our smaller one. Take a case. Let's say the array is 25, 40, 60, 10, 30. What we do? We take 20. It's no previous, so there is no point of checking it with its previous element because previous one. I'll go with 1, 5. We see that 20 is below the fact, so we swap it 5, 20, 40. 60, 10, 30. Okay, let's we see about 40. 40 is bigger than 20, which is smaller one, so we not need to compare. This is 60, let's also smaller one, so we not need to compare. We see 10. 60 is bigger than 20, so we compare it and swap it because 60 is bigger, so we swap it here. Now our value is 5, 20, 40. No, 40, 10, 60, 30. Now you see 10 is again bigger than 40. 10 is again smaller than 40. 40 is already bigger than 10. You see that 20 is also bigger than 10. So we swap it again. We got get an element and then we swap it with all its previous elements and then we find a smaller than it. And we find a smaller than the other element. Okay, so we are here. We check 6, 30 is also smaller now, so modified array is now 5, 10, 20, 40, 60, 20. We see 60 is bigger than 50, so we swap to swap here, after swapping we get 5, 10, 40, 30, 60. 30 is bigger than 40, 30 is smaller than 40. And then there is 60, its previous element is 40, which is smaller than it, so there is no need of swapping. So this is the basic fundamental of this selection sort algorithm. We find an element, we compare it with its previous elements until we find a smaller one, and if it is a larger one, then we swap between these two and check out again. and I will write the code. The element which we are comparing with other is
कभी कोई कॉपी या पीडीएफ खोल के पढ़ लिया था हर हमेशा यूट्यूब खोल लेते हो
भाई मेरे को कॉपी से आठ समझ नहीं मैं
we will compare this element with its previous element, so compare should be j minus 1 y j is greater than what is j is compare it to the space element y compared to greater than equals to 0 minus 0 because comparator into my negative is after this code we are declaring compare minus minus because compare should go previous to previous until it become a first element, so we are inserting this condition to capital element. And array key is smaller than nums count. If it is, then we use count plus the position at which keys you can write it I, but it's not correct because if you write I here, then there will be a conflict between these two. We swap it again and then back to the original after key. Not key, the previous one. Suppose I have 5, then this is key, this is the index of comparator, so key is smaller than comparator, so what I do, nums comparator plus p7 with this index should be 10, this index should be nums and count minus means now this one will be 5 10, and now I compare this 5 with the elements which is previous elements, but there is no previous element, so it will not follow this condition and become out of loop. If we don't go to this condition and I can write minus count plus 1 is okay. Those after this we can go to the last question. If key is not greater than 1, we say it is n minus 2 position and compare n minus 2 position, then this key is useful. Okay. And now I will go to merge sort, whip sort, and that's all for all sorting algorithms in first year.